Imagine that this is like those people who play video games and you get to watch them as they're playing the entire video game and be so impressed by their prowess and skill. That's basically what I'm doing, except I am going through the activity that students worked on in class on Tuesday. Major plug for Desmos, a very cool website where you're able to create things like the card sort that we're going to be looking at today. So we've been doing some major work with scale factors. So now we need to apply all of this, and we need to think about how can you use scale factors to relate different types of objects or different sets of objects. So we have 13 cards, and on each card, figure A is the original and figure B is the scaled copy. So whatever card I'm looking at, I'm going from A to B. I need to sort the cards based on their scale factors and be ready to explain my reasoning. Well, if I'm sorting them based on scale factors, the first thing to avoid would be to just put things together because they're the same shape. So just because they're circles does not mean that I would be sorting them based on scale factor. So I want to look at things that have scale factors that are related to each other in some way. There are a lot of different ways that you can do this. I think I'm going to start looking for ones that have the same scale factor if possible. So let's start with this one, card 1. Remembering that when we're looking at scale factor, we're thinking about side lengths. I notice that I have a side length of 2 and a side length of 4. So to get from 2 to 4, I would need to double this. So I could say that I have a scale factor of times 2. And to confirm that, the bottom side length of 3 would double to get me a side length of 6. So let's see if we can find anything else that has a scale factor of 2. Well, this one looks like it's getting bigger. We went from 1. So 1, 2 is the diameter to 1, 2, 3, 4, 5, 6. So 2 to 6, that would be a scale factor of 3. So that's not the same. We're going to keep that over here. Both of those are getting bigger, you notice. This hasn't changed in any way. So if it's not changed, that means every side length would be multiplied by 1 if we needed to talk about a multiplier. So this would have a scale factor of 1. So I'm going to organize these. Scale factor of 1, scale factor of 2, scale factor of 3. Let's look at this. In this one, I also see no change. Pac-Man guy has not changed when I get to B. So that tells me that every length would remain the same, which means I need to multiply it by 1 because that's my identity. So scale factors of 1. Now we have 2 of them. If we look at those shapes, in both sets, the original and the copy are identical. Okay, so let's look for other things that are getting bigger, other things that might be doubling. How about here? We go from 1, 2, 3 on the bottom side length to 1, 2, 3, 4, 5, 6. 3 to 6, that would be a scale factor times 2, doubling. And just to double check, 1, 2, 3, 1, 2, 3, 4, 5, 6. So times 2. Awesome. That can go with here. Now we have 2 that are times 2. Or doubled. Let's get this one. 1, 2, 3, 4 goes to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 to 12, I would need to triple that or times 3. 1 to 3 would also triple on the side length. So this is a scale factor of 3. Here, well, it's kind of hard to see. Let's see if we can see it any better when it's smaller. 1, 2, 3, 4, 5, 6 goes to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18. 6 to 18. 6 times 3 is 18. Aha, it's another scale factor of 3. Nothing else is getting bigger. Everything else is getting smaller. So that tells me none of these are going to double or triple. If anything, they're going to be cut in half or cut in a third or cut down in some way. So looking at this one, we go from 6 down to 3. Well, 3 is half of 6. Looking at the side, 2 is half of 4. So I would call this a scale factor of 1/2 times 1/2 because everything is half of the original. So let's keep our times 1/2 up here. Over here, 1, 2 becomes 1. Ah, it's cut in half. 1, 2, 3, 4, 5, 6, 7, 8 goes to 4, cut in half. If you look on that side, 3 goes to, 1.5. Everything has been cut in half. So that also has a scale factor of 1/2. This one, a little bit harder to see what's going on because we don't have vertical distances to look at as much, but I could look at the distance just from the top to the bottom, the height of this entire figure. So from that top point, 1, 2, 3, 4, 5, 6, 7, 8, all the way down to the bottom point. And for B, it's 1, 2, 3, 4, all the way down to the bottom point. So 8 down to 4. 4 is half of 8. So that's also cut in half. Now we already counted this one before with the previous because it looks identical to that other shape. We've just swapped which one's A and B. So now it's A over to B, or 18 down to 6. 18, a third of 18 is 6. So the scale factor here would be times 1/3. 1, 2, 3, 4, 5, 6, 7, 8, 9, down to 3. 3 is 1/3 of 9, so another scale factor of 1/3. And then 1, 2, 3, and notice I'm just finding a length that I can look at easily to compare because I already know their scale copies. So 1, 2, 3 down to 1, 1 is 1/3 of 3. So I have everything sorted. We have our scale factor of 1/2, 1/3, 1, 2, and 3. So things to notice about these piles. There are certain ones that made our shapes get larger, over on the right of my screen. Certain ones where the shape stayed the same, and certain ones where the shape got smaller. Things to notice about this. When the shape got smaller, the scale factor was a fraction that was less than 1. It was like dividing it down or cutting it down, so it was a fraction that we were multiplying by. It's a fraction of the size. When it was the same, we had a scale factor that was exactly 1. And when the copy was larger than the original, we have a scale factor that is greater than 1. So that covers all of our numbers. If it's less than 1, if it's 1, or if it's greater than 1, which is pretty nifty. So let's look at 2 in particular. We've got card 10 and card 13, and I already noticed that the shapes were the same, they were just flipped. So in card 10, the scale factor was 3. In card 13, the scale factor was 1/3. The shapes were the same in both cards, just flipped in direction. With a scale factor of 3, the shape tripled in size. With a scale factor of 1/3, the shape shrank to 1/3 the size. So if you started at the A on 10 and you multiplied by 3, you would get to the A in 13, and then when you multiply by 1/3, you'd get back down to that original shape. So they kind of undo each other. Undo each other. And we call these numbers reciprocals. Two and 1/2 are also reciprocals. So anything where they are doing the same type of action, just in reverse, those are called reciprocals. And I would subtract that. Alright, how about here? Oh, we already talked about this one. The copy is the same size as the original. The scale factor is 1. So that is a special case. Only when the scale factor is 1 do you end up with a copy that's identical to the original. And that's where we stopped in the main part of class yesterday. We looked at some other things that I can walk through in case you're interested. We looked at the scale factor if you went from a large triangle down to a smaller one. So if I paid attention to this, I would say 1, 2, 3, 4, 5, down to 1. So how would I get from 5 down to 1? It needs to be a scale factor less than 1 because it is getting smaller. And it's going down, so that is 1/5. Some people might say divided by 5. That is the same thing as saying times 1/5, but when we're talking about scale factors, we want to say times. We want to think about multiplication. In this case, we have a trapezoid, and the scale factor is 2. So that means that every side length, every distance really at all, needs to be doubled. Now this is tricky because I have diagonal lines, but I can pay attention to things that are on the grid, so like these horizontals and verticals. So that's what I'm going to do. I know that I have 3 along this vertical here, so I'm going to come up 1, 2, 3, 4, 5, 6, and just put a point there and a point there. And then I know this is 2, so I would now come 1, 2, 3, 4 over, and 2 up, and we got to double it, so 1, 2, 3, 4 up. That's going to be a point. Connect that point. Connect that point. Then 1 over, so I'm going to have to double that, 1, 2, and 2 up, and I have to double that, so 1, 2, 3, 4 here, and then I can connect my points. And then I can get rid of my kind of marker lines and just have my shape left. So it is now twice as large, even though I didn't actually measure out these side lengths here, because everything else is double. The side lengths I have drawn will also be double. Here we have a scale factor of 3/2 to get from the original to the copy. So if it's 3/2, that's greater than 1, so that tells me that everything in the original is going to get bigger. And it is going to get bigger so that everything here is now 1.5 times the size of the original, or 3/2 the original. Where if I had 3 here, 3 of those, well, let's cut that down since we're saying 3/2. We have 3 things here. Halves, I would only want the 2. So this would now be 2 long. Here, 1, 2, 3, 4, 5, 6. I could break that up like this. Now I have 2 halves. I only want 2 halves, so it's going to be 1, 2, 3, 4. 3, we already figured out. I'm just going to want it to be 1. Oh, excuse me, 2, because it's 2/3. 3, again, I'm only going to want 2. And then that tells me if it was 3, I would only want 2 here. So looking at this, my shape is identical, my angles are identical, and it has gotten larger. And if I took 2 and did 2 times 3/2, I would get 3. Ooh, these are identical to each other. That's a clue. Scale factor is 1. And here I'm not going to go through this one because I would want to use a ruler, but if I wanted to say that the scale is 3, everything is going to need to be multiplied by 3, every length in here, to get the original. So, big things. Knowing how the scale factor affects the change in size. Is it getting bigger, larger, or is it staying the same? And what are reciprocals and how do they kind of relate to each other when you're looking at scale factors?